400,000.
Ready? Okay. So it's a really great pleasure for me to welcome back Professor Walid Najjar in this second visit to Politecnico di Milano after many years. Walid Najjar is a professor of computer science engineering at the University of California, Riverside, where he was also a director in the last 5 years. And his research areas are related to computer architecture and configurable computing, especially for high-performance computing, embedded systems, and reconfigurable architecture and compilers as well. So he also a ACM distinguished scientist and fellow of the IEEE. So welcome, Walid.
So me being here is completely an accident. I never intended to do a PhD. I stumbled into a PhD, never intended to be a university professor. I stumbled into that. When I became a university professor, I never intended to ever be in administration. And I stumbled into that. So this is the result of stumbling accident after accident after accident. I realized we have a big problem. Problem is we're very undisciplined. We still don't know what we are about, our discipline, right? Compared to astronomy, Aristotle measured with very little error the circumference of the world 2nd century BC, right? So they had a lot of time to think what astronomy is about. We don't. In addition, we have a booming industry, which is pushing a lot of us in directions of research, whether they're important or not, doesn't matter. And it's requiring a lot of our product. Our product is graduates, bachelor, master, PhD. And we've had 75 years of continuous innovation. 1950, more or less. And enrollment is going through the roof. I'll show you lots of graphs. I'm sure it's the same here at Politecnico. We have a very hard time, we at least have a very hard time hiring good professors. We get lots of candidates, and it takes a lot of time to go through all the files. And we used to have classes of 30, 40, upper division, 40. Now it's 150. And there's nothing we can do about it. It's the same for you.
It's worse.
And we are still trying to figure out what's the core of computing. You take any discipline, science or humanities, you say, we need to teach our students some math. You look around, what is the math needed for somebody doing biology? You know, you can see it. This, you need some statistics, probability, this, and that. What is the basic knowledge of computing, informatics? I don't like informatics, I prefer computing. And I don't think computing is science, but it's a different story. It's an engineering discipline. What's the essential need of computing for a physics major, a civil engineer? Because some data. Last graduation year, 42% of BS given at MIT were in computer science. Couple more years, they would change their name to Massachusetts Institute of Computing. Forget everybody else. They got it. That went in 10 years from 23% to 42%. We have result. At Stanford, it went from 8 to 18. Of course, MIT is only technology. Stanford, they have all sorts of problems. At UCR, we went from 770 to 2,400 in 10 years. This is the first graph. Average undergraduate per department per unit, cumulative change from 2006 to 2022. This is from the Tolby survey 2022. 2023 is not out yet. This is the latest one. This one is the average tenure track faculty here. And this one is the average teaching faculty. So teaching faculty are professors who are dedicated to teaching. They don't have to do research. At least in the University of California, they can do research, but they don't have to. Right? It's complicated, but it's a newer thing. Okay, so this is 6x, 2.8x, 1.5x. So we're overwhelmed. Feel free to interrupt. Demand is growing, production capacity is constant or decreasing because also industry is hiring a lot of professors. It's worldwide. It's a historically unique phenomenon. We are rapidly becoming a service discipline. Service discipline in the sciences is math and statistics. They're service disciplines. They help others. Their own majors are very small. Most of what students they teach are from other majors. But unlike these other two disciplines, we have a huge major enrollment, and we have a multi-trillion-dollar industry in our field, right? There's no multi-trillion-dollar industry in statistics. I mean, actuarial studies is important, but not very big. This is another graph. This is the change in percentage and number of BS awarded in different disciplines between 2010 and 2020. CS plus 20%, roughly, yeah.
The people is no longer interested in religion and theology.
No, right.
No one not there.
Engineering plus 3%. Look who has not changed, health and medicine.
Oh.
Which is worrisome because we need more and more doctors. The population is growing and
elderly. The elderly population is growing.
That's for sure, but the world population is also growing.
I'm thinking this is a typical problem of Italy, but I see that
Worldwide.
And you notice that all of these here are humanities, and we'll come back to that. And this is the problem because I'd like my grandchildren to have good humanities teachers. Humanities are important, it's not. Okay. This is share of computer science and select humanities degrees at elite universities. Okay, this is the point. In 2016, this is humanities, this is computer science. They cross. Another one is this one. This is nationwide. This is 2020. This is CS, the green. This is all humanities, and by 2024, they would have crossed here. And the sciences keep growing, which is good. This is at UCR, this is freshman enrollment from 2013 to 2023. You notice this drop here, it's intentional. We managed, I stepped down in spring here. I was there for 5 years. I've been working on, please, we cannot get any more students. We want fewer students. And they finally, because it's not under our control, the enrollment of undergraduate. We control the graduate, not the undergraduate. So, and not only this is good, the quality of students is way better because we're bringing fewer. Here, it was a huge problem because we didn't know about this jump till 1 week before classes. We were running out of seats in the classrooms. We were getting students and we didn't have seats in the classroom. This is total enrollment, PhD, master, undergraduate, bachelor's. This is in computer science and engineering. And we have also data science and computer engineering, of course, and robotics. They take essentially the same courses the first 2 years as a computer science major. So the stress on the seats is even bigger. You see a big jump in masters, and now it's constant. Number of PhD students is roughly constant. And of course, the enrollment in undergraduate. So 3x the undergraduate, 7.3x the master, 1.6x in PhD over the 10 years. And I don't show it here, but 4x the enrollment in service courses. So these are courses for non-majors. We have only 3 of them, 3 courses. Faculty, we went from 33 to 42, and lecturers from 6 to 10, which is very small increase compared to the normal. So, computing as a service, which discussed already. What is the core knowledge? Tell you an anecdote. When I was a graduate student, I had this friend who was doing a PhD in statistics. And one day he said, "Oh, I'm teaching a course." I said, "Yeah, what course?" He said, "Biostatistics." I said, "What is biostatistics?" He said, "It's statistics for people who do life sciences." Good, so what difference is it? It's the same, but all the examples are from life sciences. Okay, next semester, what are you teaching? Oh, econometrics. What is that? Statistics for economists. So I said, all the examples are exactly, you got it. It would be fun to do that if we were like statistics, that we don't have thousands of students that we have to teach. But we don't have the resources to computing for life sciences, computing for economics, computing for we get a lot of students coming from various major graduate students, PhD students. I'd like to take a graduate course in AI. Okay, good. Take about a year, year and a half of courses. You need to know programming, algorithm, data structure, basic computer organization, and AI, and then you can take a graduate course in AI. Oh, I don't have time for that. We don't have that course package for, what is the core of computing? Math, physics, chemistry are covered in high school. Our field is not. a third of our students have had computer science in school, and usually 1 year of Python, which doesn't, which is good. But. So what's the core of computing? Programming, data structure, algorithm? Yes, good. Okay. In my opinion, Boolean logic, truth table, finite state machines is important. There are people who argue, no, you don't need those. Okay. Operating system, maybe. Parallel algorithms, maybe. Computer organization, networking, wired, wireless, depends. AI, ML, of course, everybody wants to take AI, ML today. You know. So where do we start? We teach 4,500 non-major students every year in service courses, which is various form of introduction to computing. And there's a huge demand for training in computing. And in the US, there's been recently a lot of discussion about CS plus X. CS plus X essentially is computer science major with a minor in X. We are introducing that in our department. We're starting with CS with digital arts. So for movie productions, for animations, and we have faculty who work on these. But this is not what other disciplines want. They want X plus CS. So give us a minor in CS, possibly less than a year. We can't, because your students come from high school not knowing anything about computing. So we have to start from zero, unlike math and other sciences. So never before has an academic discipline witnessed such changes, right? It's a new. And I mentioned the multi-trillion-dollar industry, so we need to innovate. And this is what we academicians who were in research, this is what we've been doing for many years. So I thought, let's orient our thinking to how can we innovate and I have to be honest, the pandemic helped us a lot in that it forced the whole academia to shift. And then it opened the possibility of now we can do this and we can do that. Whereas the administration in the past would have said, no, you can do this, you can do that. Right? How do we teach very well a large group of students? We've never done. I never done. This is new material to them, testing them accurately, avoid cheating. Cheating is a big problem. The code word is scalability and efficiency. And this is what we have been working with in computing, scalable computing and efficient computing. So we know these concepts. I'm going to talk about 3 initiatives. The first of them is flipped classrooms, which is talking yesterday with Nicoletta, and said they use that. The concept is the students study before they come to the class. Especially important in lower classes, first year, second year. They study before, they come and they do practice with the supervision of the professor and the teaching assistant in groups or individual, depends. We have documented, my colleagues have published papers on 6E and increased success rates, lower failure rates in the next class, the one that's dependent on it, requires, of course, additional people in the classroom and more TAs, and it requires resources. I was the chair for 5 years, so I had to worry about the money. The other thing is learning clinics. Learning clinics is orthogonal to the class. There's an undergraduate student, third year, fourth year, sitting behind the desk in some room. And on his desk, it says CS1, CS2, CS3, for example, whatever classes. Somebody is available there 8 hours a day, open. Any students can walk in and say, you know, I didn't understand this thing that the professor was talking about. What's the pointer? Okay. So he will explain to them. They call this peer-to-peer education. It works beautifully, you know. Maybe it's something psychological that the fact that it comes from an older person, but when it comes from somebody their age, it works very well. The students who are the clinicians, they love it. The students who use it, they love it. We noticed a big increase in the success. Of course, we pay those students to do that. The testing center is the third concept here. This started with the pandemic. We went online. And now we have to do the testing online. I discovered that the course management system that we were using, it's called Canvas, has quizzes that I can set up. And it's, you know, clicks, you have to click. So it's discrete, not writing essays. But the material I teach, I can test it like this. So I spent a lot of time developing a very large database of questions in groups. And I told the students, we'll have a test every 2 weeks. Every chapter, there'll be a test. I'll open the test for 48 hours. And you can take it from home. We're still remote. And it worked. And I told them, the questions are randomized and there's a large question. You won't get the same question as your friend. And I got a lot of correct answers for the wrong question. They'll be on the phone. Oh, question B, what are the answers? It's the first, the second is true, it's false, you got a different one there. Which is proof that it worked, but it's also proof that there's cheating. So the concept of the testing center is not something we invented, but after the pandemic, when we went back, we started adopting it. Frequent testing is better than having 1 or 2 exams during a quarter or semester. Yes?
Was it open book? Like these tests, were they open book?
When they were at home, I couldn't control them.
Right. So the question were designed to be, say, challenging, even though it was like.
Yes, yes, yes. So when we were still in the pandemic and remote, the campus, in its big wisdom, assigned a colleague to do a survey. How did we manage to transition to online? And And she asked to meet with me. I met with her. I said, I have good news and bad news. The good news is we have the most tech-savvy student population on campus. We transitioned in 2 days, all the courses were working. Wow, great. What's the bad news? The bad news is we have the most tech-savvy student population on campus. Cheating is through the roof. But you know, you can have them turn their camera on and da. Said, you know, 200 students, 3-hour exam, 600 hours of video. Who's going to watch that? Right? I mean, you're kidding me? And plus, have you ever considered the fact that the student is sitting in front of his computer and has a mirror here that can see the screen, and then a camera in front of the mirror that's connected to the friend who's giving the answer? Said, oh, said, I told you we have the most tech-savvy student population on campus. What do you expect? I mean, you know, we cannot fight cheating. Let's try to avoid it. So the concept of a testing center, which now we have implemented, not for all the courses yet. So higher sampling rate is better accuracy. It has been shown to reflect much better the ability of the students. And the students love it. So it's impossible to proctor, even in person. We're sitting in this auditorium that have 200 students back together, right?
I know the problem.
We all know the problem. You cannot, you know. Plus, it's taking class time to give an example, if, you know. So the idea is, I'll come to this, online test, log browser, computer log vector, but it's not an online test at home. A randomized question from large question banks. The test is open, for example, every 2 weeks, you have a test. The test is open for 5 days. 12 hours a day. You go into a test room. You make a reservation before. You say, I'm going on Wednesday at 4 p.m. You're given a station number. You go, somebody checks your ID, that you're who you say. You sit, you put all your belongings under the table. The browser is open only on the test. You take the test, you see your grade. Immediately, grade. You go. And when I teach like this, I give the final option and comprehensive. So I give 5 exams, quizzes like this. I drop the lowest grade. We all know that, especially when exam time comes, grandmothers tend to die very often. Right? So, oh, I'm sorry, I can't, you know, plus you had the whole week to take the 5 days. And I drop the lowest and I make the final option. The reason I make the final option, in the United States, we don't give a numeric grade. We give A, B, plus, minus, da, 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 da. So if you have a grade that it's possible with a good performance on the final to move from B to B plus, let's say, by all means take it. If you have to get 200% to move from B to B plus, it's not gonna happen. Go study something else. Cheating is a big problem. It's so easy. There are many websites and apps that help the students. Check. Anybody's heard of Check? Check it out. Course Hero. Okay, a colleague of mine teaches algorithms, gave an entrance exam online. And he knew about Check, so he went on Check while the students are taking the exam. The exam is an hour. And he checked within half an hour the answers to the exams were on Check. And Check is not free. You pay, not a lot. we're guessing $10. So one of the students, they paid with PayPal or something like that to somebody in China, India, Russia, Zimbabwe, I don't know, somewhere in the world, $10, and all the answers were there. It has and will have even bigger, major impact on our product, which is high quality student and highly ethical teaching environment. We cannot fight cheating. I have colleagues who spend way more time than they should being the policeman of the students, and in the UC system, it's such a I don't know what the word is, but it takes 6 months from the time you report a student for cheating till you get a closure on that case. Okay, and if you have a class of 200 and you're reporting, 5%, that's 10 students. That's a lot of work. I don't have the bandwidth for that. So the testing center is a good option for that. So this is the room. The one we have 2 rooms now. We started with this one. These are the stations. There's partition between the computers, so students know. The reservation system makes sure that no 2 students next to each other are taking the same exam, because it's asynchronous. Right? You can, so you're always sitting next to. This is where the proctor sits and checks the ID and so on. Every one of these computers, the cache, this cache is white after every exam. So there's nothing that you can. We have good hackers. In the last 3 years, twice our team of undergraduate cyber club beat Stanford in hacking. And the last time, the captain of the team was a Russian. And I go, what was he doing in high school? You come to university and they elect you the captain of the team. You're pregnant. Time for me to retire. We use a software from University of Illinois at Urbana-Champaign called prairielearn.com. That's a spin-off as a company. It's not expensive at all. So this past quarter, we had 2 rooms of 45 stations each, 18 courses, including graduate courses, 2,200 some students enrolled, 7,700 unique exams. And of course, tremendous saving in grading. So, and the students love it. You have people who are morning people and people who are not morning people. So everyone can take it. It's open 5 days a week, 12 hours a day. So far, we are only MCS at UCR. What we'd like for it to become is campus-wide, multiple locations on campus in the dorms, near the cafeteria and the library, places like this. And spread to all the UC campuses. So somebody who doesn't live near, but lives closer to UCLA could go do it at UCLA. And other colleges, libraries, city libraries, and places like this, because we have a lot of commuter students. So students who come, let's say, 2 days a week on campus, but live an hour or 2 hours away. They work, they live with their parents, they take care of elderly parents, all sorts of situations. More than half of our students are first-generation college goers. And we have the highest percentage of minorities of any of the UC campuses. I get a lot of colleagues saying, yeah, that's all good, but the material I teach, you cannot make it digital. Multiple choice, true and false, fill in the blanks, and I don't argue with that. I say, can you make 85% of your material clear? Say, yeah, okay, that's 85%, that's no cheating in it. 15% you can spend that time grading by hand. Right? Plus, okay. So this is the conversation. An example. One of my colleagues says, well, I like to give them to write an essay on compare arrays and linked lists to implement a stack. So good, very good. I said, how many true statements can you come up with on this topic? In comparing arrays and linked lists for implementing a stack, the following, true or false. How many true statements? He said hundreds. I said, good. So now you have a database of 200 questions, because they could be true or false, you can flip them, right? That you can choose 10 from out of the 200. Do you think that will convince you that the students knows this topic? I said, yeah. I said, good. Okay, here you are. You don't have to have an essay. You have enough coverage of the topic. Right? And plus, if your question is numeric, you can write a script that generates a different question every time, random. And in the database, right? So when the exam calls for one of these questions, the script runs and generates a different question every time. Then we can share questions among professors. And plus, medical education in the US, at least, relies on 3 such exams to get into medical school, after the second year, after the third year, all done online. So if it's good for medicine, I think we can make it work for computing. The other thing that students like a lot is the frequent testing. It eliminates the last minute studying. If you have midterm, you can be sure nobody has looked at the material until 2 days before the midterm. This one, you force them. And the second exam doesn't cover the topic of the first. Right? Yeah. High frequency sampling of the variable beta representation, we all know that. Asynchronous accommodates course schedule. In some cases, it's up to instructor, the professor, to allow the students to abort. You know, I really feel I didn't prepare well for that exam. I abort. If you're doing that on Friday at 7 p.m., you fail, right? But if you scheduled it on Monday, you still have 5 days to study and take it again. And by the way, my colleagues who have done the studies on this and published papers, those who take the exams on Monday and Tuesday get the good ones, higher grades than those who take it on Thursday and Friday. Why? Because they have the confidence of, I'm ready for it, I go, I already studied the week before and some things like that. Yeah, we hope to have off-campus sites in the future. The elephant in the room, large language models and generative AI. I don't know what the humanities are gonna do, and it's their problem. I have enough problems with our own, but large language models are gonna change the way humanities teach and test. I mean, they used to ask students to write essays. This is gone, or should be gone, I don't know. LLMs can code. Much better than can write natural languages, of course, because coding is formal. And it will become much better when we have machines trained on specific languages. So let's say this is a Python trained machine, C++ trained machines, and you give it a prompt and it could generate code. So far, the code is relatively very good in small size, right? It cannot write a whole system. I started university, I'm from Lebanon. I started university in 1975. 1975, we were not allowed to use a calculator in the first year of engineering. We had to use a Slido. There were many reasons. I would like to give my professor the credit that not everybody had a calculator, so it's unfair for those who had a calculator. Part of it was they were not very familiar with that calculator. And anyway, they allowed us later. The question I'm asking here is a chatbot the same as the calculator from 50 years ago when I started the university? I mean, would it be the way that people would generate code? And then maybe small snippets of code and then put it together? Maybe. We don't know. We don't know how well they handle large software problems, and is this finally the computer-aided software engineering? I mean, we who work in the hardware have had for a long time, like, we can derive hardware from high-level specifications. Why can't the software people derive software from high-level language specifications? Right? They can. Maybe this is finally it, from prompt to software. Yeah, prompt engineering is how to recruit good coding LLMs in our teaching is still open. Biggest technology revolution ever. We need to adapt our teaching practices. The student population has changed. In the past 50 years, I think it's the same in Europe as in the United States. Who goes to university has changed. It's a much bigger segment of the population. And in our field, it's much larger number of students than ever before. And that is question.
Thank you very much for sharing your experience.
I'm really sorry I was not able to join your presentation in time, but it was very interesting. I have one curiosity. What is your opinion when testing the students very frequently, so once every 2 weeks? Does it increase the risk of students forgetting what they have studied? So they study for 2 weeks, they get tested, then they forget what they studied.
They erase whatever is in the brain.
They're gonna forget no matter when you do this. I mean, every time we are in a course, I tell my colleagues always, what does it cost you to put 2-3 slides to remind them of what was in the previous material and other courses that we took 2 years ago, 2 years before? Yeah. We forget. The important is to repeat. And Pascal said, culture is what remains when you have forgotten everything. So by repeating, we're pushing that from knowledge to culture.
No, I totally agree on this. Repeating the same, even if you test the students only once at the very end, when teaching, repeating important key points is very, very useful.
So let me, look, there's forgetting and forgetting. When you know something and you are tested on it and you did well, right? Then of course you're gonna forget. But then when it comes to a situation where you're looking at the problem and say, how do I solve this? Oh, yeah, there is this. However, if you're in a classroom and you ask the students, what is, I don't know. But you saw it in this, oh yeah, vaguely. Yeah, so when you're pushing, do you know this? They don't. But when they're faced a problem that they are working on, I mean, I see them when they do a senior design project. Oh yes, I remember this and that. You know, now it's their project. It's their the recollection comes back, right? Yeah. So I think it's. I'm not the psychologist by any means, and I'm the specialist in education, but this is what I noticed. Right? So I don't worry about, but I tell all my colleagues, whatever you expect them to know, especially if it's math, let's say somebody graphics course, they need linear algebra. Give them a summary of, with pointers, with links of what you expect them to know in linear algebra. Don't think that they come with their head full of linear, they have a lot of other things to know too, you know. And that makes a big difference. Sorry, I interrupted.
No, but you're right, there is memory in memory.
Yes.
And sometimes it's not useful to remember my memory something, but it is more important to learn how to derive this any type of results, because it is easier to remember the process than,
Yes.
than the outcome. It depends. You're right in the example you were doing about graphics and linear algebra. For a student teaching graphics, you probably in that case the student needs only to know some basic results of linear algebra, and the student doesn't need to know how to derive these
Exactly.
results, because in that case linear algebra is just one component to do something else.
Exactly.
But if you are taking a major in linear algebra,
Completely different
it's a
story.
completely different story.
Yeah. Which is the problem we face, is that we require math knowledge and we have math teachers teach it. And sometimes these math teachers teach it as if they're teaching math majors. So with the calculus course, we discovered that the professor teaching it for years was spending most of the course proving the differentiation theorem. This is not what students need, differentiation, proving the differentiation. It's enough for them to know you can take a differential in period. It has been proven once and for all already. Yeah.
I was wondering.
Three questions.
Now, I was wondering that your description of CS as like a service kind of subject, right? But then you also said it's not science, it's an engineering discipline. So my sense is that in some sense, people do like the background for CS in terms of math and algebra in high school or something. So I'm not sure that you would need to also add explicitly, right? Doing CS is more like I think it's more of a practical derivation of other disciplines. Sense.
So we're talking about computing being a science or engineering.
Yes, and also being, as you said, a service. So like statistical
Okay, so
like these two things are kind of, I don't see how they actually align.
Right, let's separate the two things first. Why is computing and engineering this? Like all engineering, it's based on science. I mean, electrical engineering is based on science, so is civil engineering, mechanical engineering, everything. Computing, what do? We build abstractions. Okay. And these abstractions are built on abstractions that are built on abstractions. The difference is you don't see anything. Whereas in civil engineering, mechanical engineering, and to a lesser degree, electrical engineering, you see things.
Unless if you open the box.
I mean, electrical engineering is the most abstract of the traditional engineering, right? I mean, Maxwell's equations, you don't see anything. It's happened, but you don't see it. In civil engineering, if you don't see it, it doesn't exist. In mechanical engineering, most of the time you see it. The time when you don't see it is thermodynamics or fluid mechanics, and these are the hardest part of mechanical engineering, right? So in the 30s and 40s, when the foundation of our field was being built by Alan Turing and what's his name? Alonzo Church, they would write letters to each other, say, I'm sending you this paper. My theorem there is even more useless than your theorem that you sent me last time. They were competing on how nobody ever would do anything useful, but it is rationally, formally built mathematics, right? We took these with the help of semiconductors and vacuum tubes before that, and we built abstraction over abstraction over abstraction over abstraction. So it's all man-made things, right? And it's an engineering discipline. I mean, in my opinion, there's no difference between computer science and computer engineering. Now, why is it a service? Because it impacts every aspect of life. I mean, everybody needs computers, right? Some people just need to use Excel. Some people just need to use MATLAB or Python. We still don't know who needs to know how much, right? But if you're getting a minor in computer science, it cannot be just one course, right? And so it has to be 6 courses or something like that. What goes into these courses is still not the topic. And because these people will get a degree in anthropology and a minor in CS and go work as programmers. I mean, it's estimated right now that 30% of all programmers working in programming don't have formal training in computer science.
Same.
They took a 3-month academy in JavaScript. So
Yeah, we know. Davide?
I was, so thanks for sharing all your ideas. I was wondering, when you prepare a course, do you prepare maybe the concept that you would like to convey to students, but also testing methodology? You prepare before, after, how do you prepare the test? So, I mean, do you adjust the test on the basis of, on how you drive the lectures, or is it just something that you do by design before starting?
okay, I'm building on many years of teaching computer architecture. This is my field. I dropped the book. I don't use a book anymore because for 2 reasons. One is social. Books are way too expensive for students, and I make it optional. And 2, I like my own way of teaching, so I put all the material in slides. I have examples in the slides because I dropped the book. Then I give assignments of homework. Every week I give 5 problems in homework. 1 will get graded, 1 of the 5. All 5 will get covered by the TA in special recitation sessions with the solutions and discussion and everything. All the questions on the exams are similar to these homework. The homework counts for 5% of the grade. That's it. I mean, basically, and you can do it in group. 2 or 3, no more than 3. Right? So I encourage them to study together. And so, yeah, I build on those, and it takes a long time to get the right way to ask questions. So there are some that are easy. You know, computer architecture, they say I give them 16 kilobyte cache with 32 byte block, two-way set associative, how many bits for the tag? Okay, and that I can write a script that will generate that. And these are easy. Others are, you know, you have to spend more time to think about it, but it's doable. It's doable. And when you have 2, 3 professors working together, very quickly you get to a huge database where, you know, you take the exam twice and you never get the same.
Well, I want to say that at least in the computer science performance evaluation topic, I am one of the members of the working group that we have founded concerning the teaching material, how analyzing critically the teaching material. It turns out that the teaching material is really very obsolete, in spite that there are new texts. The reason is because the authors wrote a new text, wrote the text, are eager to show to the world how they are very good in math. So they filled up the text of math concepts that are completely not useful for teaching.
Too conceptual.
And
Too detailed
Yeah.
derivation of
see,
mathematics.
every one of us can drive a very good car, a very good fast car, without knowing the theory of the engine, how it works, something like that. But we know something high level. So this is one of the reasons that there is a big effort in having new texts that are essentially don't talk about math, but talk about application. This is very important. The other part is, the other question is, maybe I missed. Do you allow students to have smartphones, smart cells during the text or no?
No, nothing.
Nothing?
Just what's between the 2 ears.
Otherwise, cheating is invited.
And also no auricular, no nothing like this.
No. Only then. Now, some can allow a book or notes, but nothing electronic, because electronic now means you're communicating with somebody and therefore. And no, it's not. And we have cameras in the, so if there's a question, we can go back. Yeah.
Yes. Marco, any comment?
I just have some random thoughts in the sense that I totally agree on the way we are teaching to a new generation of students, and we have to adopt new way of teaching. And it's not just a matter of teaching, but it's also a matter of testing them. I don't know if it's going to be online or not, but the thing is that the thing that I think is that they need to have specific knowledge, for sure, on the different subjects they're studying. But we need also to provide them the chance to bring them all together, in the sense that they are going to face, while they're students, challenges that they are going to be the ones that they are going to face when they're going to be out of the university. Because when they are in the university, no matter how hard and tough is the subject, they're lying, because they know that they are going to be tested in a certain way on the subject that they study. While life is going to be completely different context. And that is something that I think is something that we do have to take also more into consideration in trying to provide context in which they can really face these kind of challenges when it comes to, it was no longer statistics, it was no longer CS, it was not CS 101, it was not just automation and control, but we do have to bring them together. I may not be the expert in that subject, but I'm going to need the expert. I need to have a basic knowledge in order to be able to interact with him or her to solve the problem. So those are also few of the skills that we need to integrate somehow in what we are doing and in the way in which we are testing that. I know that I'm going to say something really controversial, but you were saying avoid cheating. Somehow I'm more in a embrace cheating. In a sense that
we do both. So in the flipped classroom, the students are working in groups, right? So during the class, the professor announces ahead of time, you're going to be working on developing this piece of code. Right? And you already formed at the beginning of the class the groups of 3 or 4, whatever, and they sit together around the table and they're working on this, and there are professors and TAs going around checking how is it going. You have questions, you have challenges. And then sometimes comes in and says, okay, individual work on this, you have 15 minutes to write this piece of code, and they're supervising for 15 minutes, nobody's cheating and this and that. And they write a piece of code that they submit electronically on their own computer. And so then you can tell what's the individual work, what's the group work. If you have a super smart student in one of the groups, he's dominating the others, but So we have both. We have a lot of courses where they work on projects throughout the quarter. So that's also group work. There's a course that I taught one that's the senior design project. They do, the whole course is a project. They do have to do a presentation. So oral presentation is important. They took courses before that on communication. And I quiz them individually on their role in the project and things like that. Takes 3 sessions of 4 hours each to go through all the students. So you have both. There you could have cheating. I tell them, look, if you find it on GitHub, why are you stupid to go start writing? No, get it from GitHub.
Exactly.
In your report, write that it's from GitHub. Right? Because if you're going to convince me that you wrote it yourself, I've been around for too long for that. Right? Plus, I tell them this project course, it's probably the most important for your interview. I said, why? I said, because the interviewer will look at you took algorithm, operating system, compilers, architecture. Oh, senior design, what did you do your project on? And if you say, I did something that's gonna save humanity from bullshit, I just replicated a project that other people have done, but I used from GitHub, and like one group of students, this last one, face recognition on an FPGA board. They downloaded things from GitHub, they wrote things on there, they wrote interface and wrote the driver on the camera, and when they did the demo, they pointed the camera at me and says, Walid, Najjar, that's honest. They have only 10 weeks, this is what they managed to do, and this is great, because they can say, I made a face recognition system. No, I didn't write it from scratch. I didn't fabricate the FPGA either. Yeah. So yes, this is when we embrace cheating, but we don't reinvent the wheel, right?
exactly.
Yeah, yes, absolutely.
The reason why we introduced it also in our master course on multidisciplinary project, where the students can try to introduce this kind of collaborative testing on a real project. I strongly believe this is really important because it's the first approach you have to the thesis work. Will take a lot of time to them.
Yeah.
Forward.
No, I say we're a young discipline. We're still young, 75 years It's not.
Okay, so thank you again, Walid, for
Draw the line.
Grazie.
Marco, che sono le poste.
Marco, questo